we go to example 2. Okay, example 2. Example 2, if vector A is 2 alpha negative 1, vector B is alpha 3 are perpendicular. Find the value of alpha. So it will say that perpendicular, automatic, vector A dot vector B is equal to 0. If you can't remember, you still remember this formula. It's okay, just substitute. Okay, remember the formula. Cos theta. Okay, perpendicular means that theta is equal to 90. Then substitute cos 90 is equal to 0. Means that we have the equation. Vector A dot vector B is equal to 0. Okay, then okay, using the given component, okay, substitute. Okay, substitute. Okay, can change in the matrix form to alpha negative 1 dot alpha 3 is equal to 0. Then for component I times 2 alpha plus alpha times alpha squared, okay, plus negative 1 times 3 is equal to 0. Is equal to 0 to show that the two vectors are perpendicular. Okay, so 2 alpha plus alpha squared minus 3 is equal to 0, get quadratic. Okay, and factorize or arrange this one to this form. And factorize using your calculator, you can factorize alpha 3 and minus 1. Okay, therefore alpha is equal to negative 3 or alpha is equal to 1. Okay, settle. Okay, for example 3, determine which pair of the vectors are parallel. Okay, try it. Parallel means that the two vectors parallel. Okay, say that this vector, this is vector A, vector B. Okay, parallel, vector A, vector B, or this one in the same direction or in different direction. A, vector B. So for this one, we can write vector A is equal to lambda vector B. If we can write this in this form, find the lambda. Lambda is constant. Means that you can say that the two vectors are parallel. Okay, try part A. Part A. For part A, I, J minus K show that to show parallel with the negative I plus J plus K. Say, let's say this is vector A. This is vector B. Okay, we're going to show that vector A can be written like this. Okay, in this form. Okay, and it implies that I, okay, but I minus J minus K lambda negative I plus J plus K. Okay, and the component I, okay, here is 1 on the left hand side 1. Okay, on the right hand side is negative lambda. Therefore, lambda is equal to negative 1. Find again for component J. Component J. Okay, negative 1. This is 1. 1 times lambda. So, lambda is equal to negative 1. Component K. Okay, negative 1. 1 lambda. Therefore, lambda is equal to negative 1. You get the same value for lambda. It implies that, okay, vector A is equal to negative 1 substitute lambda. Okay, vector B. Or A is equal to negative B. Okay, this is the way we write. Say that you want to write in this form. Okay. Vector A equals lambda vector B. Right, in this form. Okay. So, one component I, component J, component K. This one component I, J, K. Component I, okay, 1 equals negative lambda. Therefore, lambda is equal to 1. Component J, negative 1 is equal to lambda. Component K, negative 1 is equal to lambda. Okay, therefore, A is equal to negative 1, B. Or A equals negative vector B. Okay, settle. Therefore, the two vectors are parallel. Okay, done. Settle. Go to B. Determine which pair of these vectors are parallel. Show this one for B. For part B, which one parallel, right? Okay, let vector A is equal to 3i minus 2j plus k. Vector B is equal to 3i plus 2j minus k. Okay, and if this one parallel, we can, if vector A is parallel to vector B, this one can be written vector A is equal to lambda vector B. Okay, and then write the vector A, 3, negative 2, 1 in this form, in the matrix form, is equal to lambda 3, 2, negative 1. Okay, we're going to find lambda, right? Okay, for component I, 3 equals 3 lambda. Therefore, lambda is equal to 1. For component J, negative 2 equals 2 lambda. Therefore, lambda is equal to negative 1. Okay, and check. Okay, this is not equal value, and you can stop. You can conclude that the two vectors are not parallel. Or you can have double check for component K. 1 equals negative lambda. Lambda is equal to negative 1. Okay, this one consider not equal, negative 1 and 1 means that you cannot write in this form. We can say, we can conclude that vector A, the two vectors are not parallel. Okay, because cannot be written in this form. Okay, settle. Alternative method, you can use this one formula. A dot B is equal to modulus A modulus B cos theta. Okay, parallel in the same direction, theta is equal to 0 degree. Parallel in the different opposite direction, theta is equal to 180. Okay, then it means that you need to show vector A dot vector B is equal to modulus vector A modulus vector B. Okay, positive. This one positive or negative. Why negative? Because of cos 180 cos 180 is equal to negative. Okay, if can be written in this equation statement, means that the two vectors are parallel. Okay, for A dot B, okay, find modulus A, modulus B, and find A dot B. Okay, you have find A, vector dot B. Okay, the A vector, this one is 3, negative 2, 1, dot, okay, dot 3, 2, negative 1. Okay, find this one, okay, dot product, 9, 3 times 3, 9, plus -2 times 2, -4, plus 1 times -1, -1. This one is equal to 4. Okay, then find modulus A, vector A, 3 squared plus -2 squared plus 1 squared. Okay, and this one is equal to 14. Modulus vector B, 3 squared plus 2 squared plus -1 squared. This one also 14. Okay, plus that modulus vector A times modulus vector B, between this one nothing, okay, just leave it like this, is equal to 14 times 14 is equal to 14. Okay, 14. So the value of A dot B is not equal to the value this one. Okay, so with A dot B, value A dot B is 4. It's not equal to this value, modulus A times modulus B. Okay, we can say that 4 not equal to 14. Therefore, the two vectors are not parallel. Or vector A not parallel to vector B. Okay, settle. Okay, this is alternative. Okay. Okay, for exercise, the angle between vectors A, vector B is cos 1 over sec 84. Find lambda. Okay, so from this formula, okay, cos theta. Or remember the formula, cos theta is equal to A vector dot vector B is equal to modulus vector A modulus vector B. Theta is equal to cos vector A dot vector B over modulus A modulus B. Okay, and then we can conclude that, okay, compare, okay, what is inside the bracket. You can say that 1 over sec 84 is equal to vector A dot vector B over modulus A modulus B. Okay, then first you need to find vector A dot vector B. Okay, change to matrix form. 1 lambda 2 dot vector B 2 3 1. Then component I times component I, 1 times 2, 2, plus component J times component J, lambda times 3, 3 lambda, plus 2 times 1, component K is equal to 2. Okay, this one is equal to 4 plus 3 lambda. Settle for this part. Then you need to find modulus. Modulus vector A, modulus vector A. Okay, 1 squared 1 plus lambda squared plus 2 squared 4 is equal to 5 plus lambda squared. Then find component, find magnitude for B, vector B, square root 2 times 2 squared is equal to 2, 4. Okay, plus 3 squared equals 9, plus 1 squared 1 is equal to 14. Okay, 14. Then, okay, means that from here, okay, from here is equal to 1 over 84. Okay, A vector A dot vector B over modulus vector A modulus vector B is equal to 1 over 84. Okay, and substitute 4 plus 3 lambda over modulus A is equal to 5 plus lambda square, 5 plus lambda square. Okay, and then modulus B is equal to sub 14 is equal to 1 over sub 84. Okay. Then simplify. Do squaring both sides. Square both sides. Okay. And then is equal to 4 plus 3 lambda squared over 5 plus lambda squared times 14 is equal to 1 over 84. Okay, simplify. 84 times, okay, expand 16 plus 24 lambda plus 9 lambda squared is equal to, okay, bring up, okay, 5 times lambda squared times 40. Okay, then expand until you get 53 lambda squared plus 144 lambda plus 91 is equal to 0. Okay, expand, expand between, I skip, expand. Okay, then quadratic, factorize or use calculator to find lambda. Okay, here is 53 lambda plus 91 lambda plus 1. Okay, it means that therefore lambda is equal to negative 91 over 53 or lambda is equal to 91. And double check because all the one involve third or square root. And if you check, okay, this value negative 91 over 53, okay, doesn't satisfy the equation. Okay, substitute in this in vector A, okay, and find vector A dot vector B and try to read again. This one not satisfied. So the answer is only lambda is equal to negative 1. Done.